Good day, sir. Today we'll be presenting on our project. We are from Lab Session 2A, Group 2, and me, myself, Arshini, my team members, Karina, Nur Naima, and Aldukater Ahmed. Moving on to the content, we're going to present on the introduction, AWS services, Phase 1, Phase 2, Phase 3, Phase 4 layout designs, demonstration, and reflection. Next, introduction. Our website is responsive e-commerce platform designed for selling clothing items, and it's visually appealing homepage with smooth animations. Homepage features special offers to attract visitors, and also users can view items based on categories like men's, women's, kids, and accessories. Dedicated category pages for browsing specific product types. Users can edit, remove, and add items to their shopping cart. Cart page provides a summary of selected items before checkout, secure sign-up and login forms or for users, authentication and administration. Certain functions like order history are accessible only to registered users. Authenticated contact form for inquiries or comments to site administrators. Authenticated payment page ensures safe transactions for users. Integration with popular payment gateways for easy purchases. Well-designed footer with links to important pages like privacy policy, terms and conditions, and social media pages. Footer enhances professionalism and usability by facilitating easy navigation and access to relevant information.
Good day, I'm Karina Jitko and I'll be presenting on the AWS services. So the services that we use during this project is Amazon EC2 for hosting the web server instance, Amazon S3 for storing and serving static website files, Amazon RDS for creating, hosting and managing the MySQL database, Amazon VPC for creating and managing the virtual network infrastructure, Amazon Route 53 for DNS services, Elastic Load Balancing for distributing incoming application traffic across multiple targets, auto-scaling for automatically adjusting the number of EC2 instances based on demand. Moving forward to the phase 1 layout design. So this is our phase 1 network design. So over here what you can see is that the diagram shows a project deployed across two availability zones, AZs, within the US East region. This basically means that the project's resources are distributed across multiple physically separate data centers, which also helps to improve fault tolerance and availability. So for the network components, we have a project VPC, which is a virtual private cloud, which logically isolate the part of the AWS cloud that we can define. It's like our own virtual network, which with complete control over our IP address range, subnets, route tables, and network access control lists (ACLs). And for the public and private subnets, the project VPC consists of two public subnets and two private subnets. The public subnets basically allow resources to have public IP addresses and be accessible from the internet, whereby the private subnets do not have public IP addresses and are not directly accessible from the internet. They are typically used for resources that do not need to be accessed from the public internet. Next, we have the web servers. The diagram basically shows two different web servers, each deployed in a separate public subnet. This basically means that the web servers are accessible from the internet. That's all from me. Thank you.
Hello sir, my name is Ahmed Dawathar and I will be explaining Phase 2 layout design. The network components. There's a virtual private cloud VPC is a logically isolated part of the AWS cloud that you can define. It's like your own virtual network with the complete control over your IP address range, subnets, route table, and network access control list. Database server. Database server is a MySQL database located in the private subnet of US East 1A. It stores the inventory information. It connects the project inventory server with the VPS using private IP address. The diagram shows two security groups, one for the web server and one for the MySQL database. Security groups are used to control inbound and outbound traffic to your resources. The security group for the web servers allows inbound traffic in port 80 HTTP and port 22 SSH. The security groups for the MySQL database allows inbound traffic from the security group for the web server, and this allows to ensure that only authorized resources can access the database.
Hi, my name is Nur Naimah binti Edogafa. My major is TCN. Today I'm going to continue on the phase 3 and 4. Phase 3 layout design. In this layout design, a virtual private cloud VPC within the Amazon Web Services cloud manage the inventory system. The system covers 3 availability zones in the US East region, guaranteeing continuous operation even if one availability zone fields. Each availability zones includes one public subnet, which houses resources that require public IP address for internet access, such as the load balancer, and one private subnet, which contains services that do not require direct internet connectivity, such as the project inventory servers. The application load balancer distributes incoming traffic among the project inventory servers to ensure peak performance and scalability. In phase 4 layout design, this graphic depicts an inventory system on AWS that employs auto-scaling for dynamic resource allocation. It displays an auto-scaling group for web server that automatically configures and terminates servers depending on predetermined scaling criteria. The project server load balancer distributes traffic among various servers, ensuring that incoming requests are served regardlessly of scaling up or down. Thank you.
So for the demonstration part, this is our first page, which is the login page. And we have already signed up earlier, so we're just going to log in using password and username we have created before. Next, as you log in, you can see the home page. And when you go to the drop-down menu, you can see the help center, order history, change password, update profile, and also the logout. And next you can see home page, products page, about page, and also the contact page. Next, as you scroll down, you can see what's popular, you can see what's recommended, you can see men's clothes, you can see ladies' clothes, and also the history you have browsed, kids' dress, and also the history you have browsed before. Next, this is our view item page. Over here, we can filter the price, the color, and the brand we want. For example, as you can see here, the Louis Vuitton, Gucci, or an etc.
So over here we have our view item page, where over here we can see the details of the product, and also you can see it in different colors. Next, what we can do is we can add our item to the cart. So this is the item that we have added to our cart. So what we can do in the cart is basically we have added items, we can remove the item from the cart, we can also edit the items in the cart, as in we can increase the quantity of the product, or we can even reduce the quantity of the product. And then we can place order. And over here we can change the delivery address, we can edit it and add our current location, the pin code, address, city, town, and save it. And we also have the order summary. We have the order summary and continue, and then we also have our payment option where we can just basically confirm. So that's our web page, and that's all from us. Thank you very much.
For the reflection part, learning AWS and crafting our own web server was a journey marked by carefully planned milestones. Creating a layout diagram in the initial stages was pivotal, detailing complex functionalities and network topologies, while shaping our understanding of the web application architecture. Hands-on implementation of AWS services including EC2 instance, S3 storage, and RDS database brought our conceptual design to life, bridging the gap between theory and practice. Refinement of our setup involved revisiting the layout diagram, documenting changes, and navigating real-world implementation hurdles, honing our troubleshooting skills and optimizing our infrastructure. The culmination of our efforts resulted in a fully optimized AWS infrastructure, confirmed through a final layout design and performance assessment, showcasing the reliability and scalability of our web server architecture. This journey not only enhanced our technical skills, but also instilled discipline and adaptability in approaching challenges. It's understood the strength of AWS as a cloud server provider emphasized the importance of exploratory mindset in learning. Ultimately, this transformative learning experience equipped us with the valuable insights and capabilities extending far beyond the confines of this project.